All right. So again, first things first, we define a method called binary search. The second thing that we do after that, binary search takes in is going to take in two things. It's going to takes two parameters, a value that you're searching for, and an array of sort of numbers. Say you're searching for a value t in a set of values. We are looking for that. That's number 2. Find the middle value in values, and you can call it m. Okay, not an issue. Create a middle value called m. We'll just call it middle value. Create a middle value of the array called middle value. Pretty simple. We got rid of this one. All right. It says if t is equal to m, then your target is found. That's pretty simple. If value is equal to middle value, return that index. If t is less than that middle value, then your new search set is going to be the half of the values before m. So it's kind of like if I open a dictionary, I'm looking for like a word that begins with D, and I end up at M, I know I'm only supposed to deal with the first half of the dictionary. So let's replace all of these. If value is less than middle value, your new search set is going to be half of values before middle value. Okay, that's pretty simple. Half of the original array before the middle value. All right. If your value is greater than the middle value, your search set is going to be half of it, and I know I'm going to be using recursion of some sort. If your search set is now empty, the value is not found. If your search set is not empty, return to step 2 with that new set. Okay, that's pretty simple. Let's translate this into real code. Number 1's really easy. Define a method called binary search. Takes 2 parameters. I'm going to be looking for a specific value, and I'm going to be given an array of numbers. Cool. 1 and 2 is finished. Create a middle value of the array called middle value. Sure. So middle value is going to be array of numbers. How do I find, so if I have an array of numbers of, like, let's say 1, 2, 3, 4, 5. How do I find the middle value, which is 3? Like, how do I do that? So let's just say array equals that, and how do I get to the middle? What is the code that I need to type?
Array of numbers length divided by 2.
Okay, that works for me. So you said if you take the length of this divided by 2 and you just access it there, that works for me. So let's create a midpoint index or something like that. So I'll do array of numbers dot length divided by 2. Do you want to round up or do you want to round down? Because like right now it's kind of like if I this is an odd number of things, right? So it's gonna impact me based on if I go up or down. So what would you like?
Up.
You want to round up?
Round down.
Round down. This is actually already going to round down. So 5 divided by 2 is 2.5, which is just going to return you 2 in computer world. So we're good with that. So the middle number is going to be the array of numbers at the midpoint index. Okay, so we just did number 3. All right, so now we're going to do a whole bunch of if-else logic. So we did 1, 2, 3 really quickly. If the value is equal to middle value, then return that index. Return midpoint index, and then we're done. If the value is less than, so else if value is less than middle value, my new search set is going to be half of the original array before the middle value. Again, if I'm looking for dog inside of a giant dictionary, I open it right in the middle, the letter is M, then I know I'm going to throw out the later half of the dictionary and only deal with the first half. So I know somehow I'm going to just do binary search. I'm going to still look for the same thing, but my array of numbers is going to be slightly different. I'm going to go from array of numbers from the middle, from the beginning, all the way until the middle index. If it is greater than, so the opposite, then I'm going to deal with the new search set is going to be half of the original array after the middle value. Again, if I open the dictionary right in the middle, it shows up at M. I'm looking for tangerine or something like that. I know I'm going to throw out the first half and just deal with the second half. So I'm just going to do pretty much the opposite here. Else if value is greater than middle value, I'm going to binary search of value, and then the array of numbers starting at the middle all the way to the end. So I just took care of number 6 here. If your search set is now empty, the value is not found. If your search set is not empty, return to step 2. So that return to step 2 is like do the binary search over and over again until you get there. So I think this might do it. Maybe this works. We'll find out. Does anyone see any issues right now? Does anything like call out to you saying like, oh, you're gonna come up with some issues right there?
So what's
It looks good. I'm just wondering what it looked like with a select case, given all the possibilities.
Okay. What do you think, Raymond?
so what's the escape? Is it the first one? The return middle point index?
Yeah, if the value is equal to the middle one, so like I've shrunk it down so much to the point where I just have that first index, and then I should be pretty good, right? I can just return that middle index.
What if the number's not in the index?
What if the number is not? What if the value that you're looking for? If I give you the number 4 and the array says 1, 2, 5, 6 or something like that, what if it doesn't exist? I can keep shrinking it, but then I get to a point where there's nothing left. So, what should I do there?
If it's not there, just say not there.
How do I know if it's not there?
If you get all the way through it and
Yeah.
you still didn't find it,
So what is that condition where I can escape? What, like all the way through it? What does that mean?
If the length is equal to 1,
Yeah.
and that number is not the index,
Yeah.
then it's not there.
Sure. So I think we can check it. It's like if the value is equal to whatever is remaining. Let's say you dumb it down all the way down to one number, right? If the value is equal to that one number, fantastic. We're in great shape. Otherwise, if we get past this, then we know it's not theirs. Because if we're looking for 3 and all we've got left is 4, this first condition is not met, so we can check that length. So I think I agree with you. So else if the array of numbers dot length is equal to 1, return, let's say, not found. Anything else stand out to you as or are we good to go?
Are we trying to find the index?
We are.
Because I'm not sure how we would return the index in this scenario.
Okay, so yeah, the answer is yes, we are looking for the index. And how do we, you said, how do we, I guess, look for the index?
Well, how do we return it? Because by the time you recursively search, and I don't want to do the like easy way out of thing. I want to think about actually tracking it, I guess.
So you cut out a little bit. Can you repeat that one more time?
I was just saying that I don't want to use the index of function that's already pre-written. Like, I'm just not sure how to track, like, how do you return the index from that original array when you finally found it, you're dealing with a much smaller array.
Sure. So I do agree with you. I think we're missing one last thing. So the issue, what we found, what Leanna is seeing here, is as you shrink down the array and you return the middle index and you're done, that is not the actual original. So it's kind of like you're always going to end up, let's say, like you start with 1,000 things, and then you end up with 500 things, and the index that, let's say it's like you found that number and it's index 250 out of 500. That 250 might not be the 250 from the very beginning. It's the 250 of the smaller array, and as you keep going further down, you're not keeping track of the original. So the idea is like between recursive calls, like as I'm calling more and more recursion here, like how do I keep track of where I started?
Well, you're gonna have to have some kind of a counting mechanism.
You have to have some sort of counter. That's exactly right. But where should I put it? Where do you think?
Every time you have it, you need to take track of every time.
Yeah.
How many times you have it.
Every time that you call binary search, you have to know where you started. Otherwise, you don't know where you're going to end up. It's kind of like taking if you're trying to lose weight or something like that, and you take a photograph. If you don't take a photograph beforehand, and the scale keeps lying to you, but you're like your weight is increasing, but you like look better. It's like the scale lies to you. So it's like you need to know where you've started in order to know where you're going to end up. So every single time, you said every single time that I call the binary search, I have to keep track of where I'm at. So I'm going to pass in something called an optional parameter. Let's say, what should I call this? Let's see. Any good idea for like an optional parameter of like how far I've come so far? Tracking parameter. I'm definitely not going with optional parameter. Well, yeah, sure. We could even just call this like I don't know. Progress index? I don't know. That's a bad name.
Snapshot.
Let's go with last index. And we'll start off with 0. Alright, so if I am at the middle index, let's say the value is going to equal the middle value. So we get really lucky and we get to the point where the value we're looking for is the number that's right in the middle. Return midpoint index is not going to be accurate. I have to add that on to last index. Because it's kind of like if I'm keeping track of how far I've gone so far, wherever the midpoint is, that's great. But we need to add it on to like the accumulation of all the places we've gone so far, and we just start off at 0. If the length is equal to 1, we've returned not found. If value is less than middle value, great. So we can deal with this in terms of like, so the value is less than the middle value. You're looking for car, and you've ended up in the M section of the dictionary. What is the last index going to be right here? Like, I need to pass in some number here. I just don't know what that some number is.
Don't know.
Don't know. Okay. But we do need to pass in something because last index is, we do need to pass in this optional third parameter. This last index equals 0 means that if you don't pass any number in, it'll just hard code it to 0 for us. So I don't actually think we need to do anything here, mostly because if we're only dealing with the first half of the thing, like all the indexes still remain the same as the original. We've just thrown out the second half. We just care about the first half. It's still the original array because it's still the first half. So I think we can just kind of leave that alone. I'll just pass in last index. Alright, otherwise, if it's the second half, I need to know where I've started. The last index is actually right in the middle, that middle index. Like, that's our new starting point. That's what we need to add on to it over and over. So I'm just going to do, I'm going to pass in midpoint index. Let's see if this works. So I'm going to do binary search of 5, and I'm going to pass in an array of sorted numbers 1, 2, 5, 7, 8, 9, 10. Let's see what we get. Let's see if anything comes out. right, so we get the number 2. Let's verify that that is correct. 0, 1, 2. We're good to go. Let's choose the number 9 to make sure that this also works. So the answer that should come out is 0, 1, 2, 3, 4, 5. The 5th number in the array is what we're looking for here. So this should return me 5. All right, it looks good to me. Let's choose a number that's not in the array. So we'll do 19. Not found. All right, that looks pretty good. Let's see what the specs give us. All right, so we have a test array of 1, 2, 3, 4, 5. I expect all of this to be true, and if I have a super big array with numbers that are out of order, it should also account for that. Let's take a look at what we've got. So we're going to run Ruby binary search spec. And it says undefined method binary search on line 3. Okay, let's take a look at what's going on here. So puts binary search 1. I don't see the issue. Does anybody know what's wrong here? What's that? It needs a require. What is that? What do you mean by that?
So the spec file doesn't see what's inside the other file, so it has to require the lines of code from the other file.
Right. So as of right now, if you take a look at this spec file right here, this is probably a small bug that we should fix. Right now what's happening is it's looking for binary search within this particular file. But the issue is binary search doesn't exist within this file. It exists within its sister file right here called binary search. So we're missing a small line. Mike, can you add that for me? Okay. So we need a require relative. Require relative is for files, and then we'll talk about require today, which is going to be for libraries. So require relative. So there's going to be a file that I need to require to run this relative to my position right here. It's called binary search. And let's see if this works. Uh-oh. Stack level 2 deep, and overall it just blows up in general. That's not what we'd like to see. What is the one case we haven't accounted for? There's one thing that we haven't done, which is the difference between the test array that's provided at line 3 and the super big array that's provided on line 12. We didn't sort it, yeah. So what? You can't have a dictionary that's out of order and then you say like, find me this word in there. That's literally going to you're kind of screwed at that point. So you need to sort this first. Luckily, it's pretty simple. We'll just do array of numbers dot sort. Sort with the bang will destructively change the original. So we get we get not found, and then a whole bunch of issues. Binary search of 1 against the test array. I feel like this should not be an issue, but we'll find out. We'll just run this one by one until we figure out which one is blowing up. Okay, the first one blows up. That's not good. I think something is missing for us. Why is this not working? I'm looking for 1. It should return me the test array. One, 2, 3, 4, 5. Anybody see the issue? Nope, test array, as long as it is somewhere it's defined, you're good to go. So, like, because you're passing it in into the array of numbers. I think there's one issue. So let's say we're looking for 1 and we split it right in half. If this is good, if 1 is equal to this, then we just return whatever that value of the index is, plus the last one we were at. If we get all the way to the end and there's still one value there, we were going to return not found.
What was the error?
It says stack level too deep.
Oh.
That's no good. Otherwise, if the value is less, then we deal with the first half. So we do 0 up until the midpoint plus the last index. Otherwise, we're going to do binary search. Oh. A couple things. One, we need to do midpoint index plus last index here. And these both need return statements. Let's just verify that this is correct. True. Okay, at least it's not blowing up anymore.
I'm sorry, what exactly did you change?
I've added two things. One of them was binary search will continuously run forever unless you have a return statement. Recursive functions will run over and over again unless unless you tell it to return. So you need to add returns in front of both of these in order to make them stop. Otherwise, they just keep running forever. And then I added a plus last index over here. Because the idea is, like, if I give you a letter, let's say it's a giant dictionary again, and I give you the word yellow, and you open the dictionary, ends up at the M, you have to keep track of that first time where you started was 0, and then you ended up at the middle. So whatever the index of M is, you need to keep track of that. When you split it again between M and Z, there's probably, let's say it's the letter U or something like that. That's the middle point between M and Z. I have to keep track of where that U is in the giant scheme of things. So I need to add that on to the end. That's why I've decided to add on this plus last index in here.
So this last index, it's equal to 0, right, or at the beginning.
Mm-hmm.
Where does it change?
So last index only comes into play when it comes to larger than the middle, because it's kind of like, again, that giant dictionary. If I were looking for the word cowboy, C is going to be less than the midpoint. So your original, like all of your indexes still remain the same because you're only dealing with the first half. Even though you're splitting it in half, but you're still dealing with the first half. So that first half, your smaller array is still part of the bigger array.
But if your last index is equal to 0, how does it affect the rest of your code? It's just, if you're adding 0 to the indexes, it's a number.
So the idea behind it is, if I had a larger word inside of the dictionary that I'm looking for, like I'm looking for like Tim inside of the giant dictionary, the M, the last index, so we have to keep track of where we started, right? So that M is, let's say, like the 13th letter in the alphabet. Then I'm dealing with like a smaller subset. So if I take in, like, let's say it's right in the middle between M and Z, like let's say T is right between M and Z, the half point of 13 is going to be 6. So if I return 6 out to the screen, that's obviously not correct because the 6th letter of the alphabet is G. So I have to keep track of that last index to know that how far I've come. I feel like I've lost like every single person.
No?
No?
Yeah, I don't understand the third parameter part. That's where I got lost.
Sure. So the question was, I don't understand the third parameter. Okay, not an issue. Let's do, I'm going to teach a few things real quick. This actually leads in quite well. So inside of each programming language, we're going to move on to a new concept, and I promise we'll come back to that third thing in just a bit. So inside of programming, every single language has built-in libraries, and libraries are very simple. They're just thousands of lines of code written in that particular language to make your life as a developer much easier. So Ruby has Ruby libraries. Those are thousands of lines of Ruby code to make your life as a Ruby developer easier. JavaScript has libraries as well. Those are thousands of lines of JavaScript code to make your JavaScript development much easier. Inside of Ruby, the libraries are called gems. It's kind of like they think it's a fun play on words because it's like Ruby is a gem, so you have Ruby gems. These are other libraries written inside of Ruby. And the place that you can find all of the like the source of truth for all like legitimate Ruby libraries is rubygem.org. You can find all the different gems that you're going to need to use for Ruby inside of here. Now, once this loads, there are certain things that are more useful and certain things that are less useful. So Ruby gems, you can see it's been downloaded 18 billion times by people as they are starting to like develop in Ruby and things like that. And when I click on gems here, this is a list of all the gems ever published in the history of the Ruby language. There are 9,073 of them in total, and you can kind of see like some of them have 34,000 downloads, 319 downloads. This is probably just not really one that you really need to use. But anything that you think like, God, like I hate dealing with time zones or something like that, someone has probably written a library to get rid of that for you. Or like when we're dealing with things like binary search, and you're like, I'm not sure what you mean by like this third thing. This is like, what if it's like if the value is greater than the middle value? I wish I could just kind of like enter into this particular point. Like if I could like set a breaking point so I know what's going on inside of my code. There's probably a gem for that. For us, we're going to start using something called pry. So I'm going to jump over to P, go down to the bottom. I'm going to open something called pry. There's a whole bunch of them. There's a little description underneath. Is there no pry? Maybe next page. Oh, it's just taking too long. I'm just going to type in here, PRY. Can you shut off the heat? Thanks. All right, so I have pry right here, and pry has 59 million downloads. This is probably something that's pretty useful. So I'm going to click on this, and again, this is just a library, thousands of lines of Ruby code that someone wrote to make my life as a developer easier. Let's see specifically what's inside of here. So I'm just going to visit the home page. God, I've never seen my computer operate this slowly in my life. Okay, so I have this pry right here, and it looks like the usage is pretty simple. I'm just going to do gem install pry, and then I just run pry. Oh my gosh, please stop. Okay. All right. So I have this gem. I want to install it, so I'm just going to run gem install. So remember, every single git command you were going to type git in the front. All the Ruby commands you're going to run Ruby in the front. All the JavaScript things you're going to run Node in the front. All the gem commands you're going to run gem in the front. So I'm going to gem install pry, which is going to download this particular library from the internet and bring it into my machine. And we downloaded Ruby gems on the first day. That's part of the giant setup that nobody really understood. As we're waiting for that, we've talked about require relative. Require relative is for a specific file. When I run require on the top, it's for a library. Again, require relative is for a file, require is for a library. So the way that I'm going to run this here is I'm going to put a binding.pry, and I'm purposely throwing it out of like usual best practices for like spacing. Like I purposely threw it all the way on the left so I know that I had to remove it a little bit later. And I'm just going to throw a bunch of other pries in here as well. So let's go 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 3, 0, 1, 2, 3. Okay. Alright, so I've installed the gem. List everything out. I'm going to run ruby binary search.rb. what binding pry allows me to do is it sets a stopping point inside of my code. So if you've ever wondered what's going on inside of my code at any particular given point, all you have to do is throw a binding pry, and it'll execute everything and then stop at a certain point. At this point, we're right in the middle of the code, so the computer is not executing anything, and we're able to do a bunch of things. We can take a look at what's the value that we're looking for, what's the array of numbers that we're currently dealing with. So we're doing 1, 2, 5, 7, 8, 9, and then if you can see, I have 4 other binding pries. These binding pries allow me to basically say, like, if this condition is hit, then stop and let me know that I've actually hit that condition. Else, if this condition has been hit, stop here, and then so on and so forth. So the way that I exit, I'm stuck here right now, and I want to move. I want to keep executing the code. So what I'm going to type is just exit, and then it's going to continuously run through the code. So I was here before. It kept running, so it hit line 8, and now here I'm stuck at line 9. Let's take a look at what value is, and let's look at middle value. Okay, so it appears that the number I was looking for is actually the middle value of the array that I had. So cool, I'm just going to return the midpoint index plus the last index. So let's take a look at what midpoint index is. It's going to be 3, it's the third thing, and then last index, which is going to be 0. Okay, so this is the case where it's perfectly right in the middle, you're really lucky, you don't have anything else to do. Let's say I'm looking for the number 5, which is going to hit this this giant block of logic right here, just the first half. So I'm going to look for number 5. All right, so let's take a look at all the things that we have. Let's see what middle index looks like. It's still 3 because we have an array of 7. That's where we've started. The middle value is going to be 7. It's that number right in the middle. And I haven't actually hit any of this if-else logic. So cool. This is a good place for me to stop. I'm going to exit out. And you can kind of see, instead of hitting the binding pry at line 9, hits the binding pry at line 15. Line 15 means that the value that I'm looking for, 5, is less than the middle value of 7. So right now, that means I'm going to have to actually run binary search one more time. Okay? So let's exit here, and again, now I'm in the second time that I've run binary search within the first time. So I've run binary search, and within binary search, I had to run binary search one more time. So this is the dream within a dream. So let's take a look at what the value is. I'm still looking for 5. Let's take a look at what the array of numbers is. It's actually just 1, 2, 5. We started off with 1, 2, 5, 7, 8, 9, 10. But now we have a smaller subset. But you can kind of see that this 1, 2, 5 here, the indexes of them are identical to the indexes of the original. It's still the 0th, 1, and first and second index of the original. That's why I don't really need to update this last index thing. Alright, so the midpoint index is 1 this time. The middle value this time is going to be 2. And let's exit out of here and see which block that we hit. So now we've hit that third thing that you were talking about. Let's take a look at the value that we have. We're looking for the number 5, but the middle value is actually 2. And that kind of makes sense because my array of numbers, you can kind of see that the 5 is the last number, but if I split it right down the middle, the number that comes in right in the middle is going to be 2. So now I have to throw away everything in the smaller half of this, and I just keep 2 and 5. Exit. Now so I started off at 1, I'm in another dream, and now I'm in another dream. So I'm 3 layers deep at this point. Let's take a look at the value, the array of numbers. And this is where this last index really becomes useful. So if I do last index, is actually going to equal 1. Because I've started shrinking down my things so much, like I have to keep track of where I've come from and how deep I've gone. Like the original array of numbers looked like this: 1, 2, 5, 7, 8, 9, 10. At this point, it's just 2 and 5. So I need to know that I've moved up, like I've shrunk it. I need to know I'm dealing with 2 and 5 here. But the original one, I need to know how far forward I've moved. I've moved forward one space. And this is the array that I'm dealing with right now. So let's take a look at value, array of numbers, last index, middle index, and middle value. So the middle value is going to equal 5, and I exit and I hit this first one. The value is equal to the middle value, so I'm going to return midpoint index, which is going to be 1, plus the last index, which is also 1. So if all goes well, I should return 2, and I believe that is the answer. 0, 1, 2. Oops. That's that answer right there. That 2. Does that make any sense to you?
So it turned from 0 to 1 based on where the value was, not by like doing a plus equal 1.
So the question was, how did the last index move, right? So basically, when we did the binary search on this, we split it right down the middle, and we kept the original. So we haven't moved forward at all, correct? Are we all on the same page with that? We haven't moved forward at all. We're just dealing with the first half.
Yeah.
Then we split it in the half again, and 5 is greater than 2, so I throw out this first half. And I'm only dealing with the second half. So that's what I'm dealing with here. I have 2 and 5, but I've moved forward one space. Like
that changed from 0 to 1.
That changed from 0 to 1 at that particular point. And then I split it in half again. The midpoint for us here is going to be this number 5. So I return whatever the number 5 is at that point. Since we have an array of 2 and 5, it's at the first index, and then we've moved forward 1 so far, so I just have to add it onto there. Would it be helpful to do one more? Yes? All right, let's do one more. Let's do 9. So Ruby binary search. So this is the first time through that we run through this. So value is going to be 9. My array of numbers is going to be 1, like everything to begin with. We haven't moved forward at all, but we know just based off of looking at this, the midpoint is going to give me 7. Well, actually, let's not guess. The middle value is going to be 7 of this array, so I know that I'm going to hit this one because my value 9 is greater than 7. I'm going to hit line 18. So I'm going to exit here, and hopefully we're going to hit this binding pry on line 18. Cool. So now I know that I need to throw a bunch of stuff away. I know that 9 is greater than 7, so I only care about the numbers 8, 9, and 10. So that means I've moved up a whole bunch already. 1, 2, 3, 4 spaces. I've already moved up 4 spaces, so I need to keep track of that as well. Because I'm going to be, the next time through, I'm going to be dealing with a slightly smaller group of just 8, 9, 10. If I return the midpoint of 9, that's going to return me 1. But 1 is not the original. Like, it's a modified version. So let's take a look at what value is. Still 9. Let's take a look at what array of numbers midpoint to number 1 is. So I'm dealing with 7, 8, 9, 10. And then this is the last index. I've already moved up 3 spaces, so I need to keep track that I've moved up 3 spaces. Cool. So we're one more layer deep. We have a value of 9. The array of numbers has shrunk from 1, 2, 5, 6, 7, 8, 9 to just 7, 8, 9, 10. So we've already cut the amount of stuff we have to look through in half. Let's take a look at what the middle number is. It's going to give me 9. If I exit here, it's going to hit this first one because the value that is 9 and the middle value is also 9. Last index. So we've moved up 3 spaces already. 0, 1, 2, 3. Like, this is where our starting point was. So we've already we've shrunk it down, and we have to keep track of how far up we've moved. So we have last index. Let's take a look at what midpoint index is here. So inside this current array of numbers, the number 9 is the 0, 1, 2, like the second place. Like at index 2 is the number 9. So I need to add these two together in order to keep track of like how far I've come. So if all goes well, I think this is the fifth number. 0, 1, 2, 3, 4, 5. So if I exit again, my answer is going to be 5 because that's how far I've come added on to like what the current index of 9 is at that point. Make a little more sense?
Yeah.
Cool. All right, let's take a 10-minute break. Actually, a 13-minute break. We'll be back at 10:15.
Done.
Mm-hmm.
You had midpoint,